This is a second video regarding solving limit reactant problems. I will go over another limit reactant problem using a chemical reaction that you will see in class. Before we start, I want you to write the reaction between magnesium nitrite and lithium phosphide. Make sure you balance the equation and include the states. Please stop the video and do this yourself. I will leave some blank time in this video to give you a chance to work on it. I hope your reaction looks something like this, where I have 3 magnesium nitrates, aqueous phase, plus 2 lithium phosphides in the aqueous phase, goes to 1 magnesium phosphide, which is a solid, and 6 lithium nitrites in the aqueous phase. The question that I have for you is, if you have 3.55 grams of magnesium nitrite and 2.71 grams of lithium phosphide, how much of each species in grams will be present at the end of the reaction? If the percent yield was 89.1%, how much of the solid was actually formed? Please follow the steps in your workbook to solve this problem. Step 1. If you have quantities of more than one reactant, it is considered a limit reactant problem. You may proceed. This is considered as a limit reactant problem because you have grams of magnesium nitrite, which is a reactant, and grams of lithium phosphide, which is also a reactant. Step 2. Pick a product. I chose magnesium phosphide in this case. It doesn't really matter which product you chose because you will get the same answer in the end. So you could do it with lithium nitrite also. Step 3. How much of that product that you chose from step 2 will you form from each reactant? So you start with 3.55 grams of magnesium nitrite and go to magnesium phosphide. And you start with 2.71 grams of lithium phosphide and go to magnesium phosphide. Please stop the video and try this for yourself. I hope you came up with 1.37 grams of magnesium phosphide and 3.53 grams of magnesium phosphide. And I hope your work looks something like this. Step 4. The reactant that gives the least product is a limiting reactant. So in this case, magnesium nitrite is a limiting reactant and 1.37 grams of magnesium phosphide is formed. Step 5. Using that reactant from step 4, which in this case is magnesium nitrite, how much of the other product will you form? The other product is lithium nitrite. So go from grams of magnesium nitrite to grams of lithium nitrite. I will give you time to work on it right now, please. I hope you got 3.23 grams of lithium nitrite. Step 6. Using that reactant again, how much of the other reactant, which is considered the excess, will you need? The other reactant is lithium phosphide. So go from magnesium nitrite to lithium phosphide. I will give you time to work on it right now. I hope you got 1.05 grams of lithium phosphide, and this is what you need for the reaction to occur. Step 7. Subtract the amount of excess reactant needed from the amount that you started with. I started with 2.71 grams of lithium phosphide, but only used 1.05 grams of it. Therefore, I have 1.66 grams of lithium phosphide left over. Step 8. Let's calculate the actual yield if the percent yield is 89.1%. The theoretical yield is calculated based on the limiting reactant. So the theoretical yield is 1.37 grams of magnesium phosphide because it is the solid. So you have this equation right here. The actual yield would be 1.22 grams. Consolidate your answers. Since I'm not going to go through your work, please put your answers together in the box. I have 0 grams of magnesium nitrite, 1.37 grams of magnesium phosphide, 3.23 grams of lithium nitrite, 1.66 grams of lithium phosphide left over, and the actual yield is 1.22 grams. If you follow these steps to solve your limiting reaction problems, you will always get it right. So please continue practicing solving these problems.